IoT protocols. IoT stands for Internet of Things. The Internet of Things is about the network of sensor devices to the web in real time. IoT devices communicate with each other over the network, so certain standards and rules need to be set to determine how data is exchanged. These rules is called as the IoT protocols. The wireless hardware used in IoT are the nodes and the base stations. Nodes or clients are the devices that connect to the base stations. Base stations are the routers or gateways. The importance of IoT protocols is the ability to interact with each other and resolve common problems is what separates the IoT devices from the traditional computers. These interactions are only possible if there is a medium or means of communication in the IoT ecosystem. IoT protocols are thus the common language that allows the devices to interact with other devices. The IoT protocols lay down standards that are adapted in every IoT ecosystem for proper functioning and to avoid the security threats. IoT protocols is classified into two types, that are IoT data protocol and IoT network protocol. The IoT data protocol handles the message or data exchange once the device is connected. The one type of IoT data protocol is MQTT. MQTT stands for Message Queuing Telemetry Transport. It is lightweight and easily transfers the data between the two or more devices. It is based on the publisher subscriber model. Here, the publisher shares the messages to the broker and the broker delivers the message to the devices which are subscribed to that broker. The broker that manages all the communication and receives all the message and distributes them to the interested clients. The broker is passes the messages based on the TCP/IP protocol. TCP stands for Transmission Control Protocol. It is based on the three-way communication. Here, the publisher first sends the synchronization message. After receiving the synchronization acknowledgement, the sender sends the acknowledgement message. After that only, the sender sends the data to the receiver. Here, the data is separated as a packets. The packets are delivered in an ordered manner, so it will reduces the error. The MQTT protocol is used in the home automation, industrial IoT and vehicle tracking system. The another type of IoT data protocol is advanced message queuing protocol. It is more complex and secure. It was used in the banking and financial sectors for secure government communication. Here, the data is sent through the broker. It is message oriented middleware. It is also uses the TCP/IP protocol. The another type of IoT data protocol is data distribution service. It does not depend on the middleman for communication. DTS gives the rise to quick results, smart decisions, revenue, and lesser cost. It is widely used protocol in IoT due to its versatility and extensible nature. It is used in the defense, autonomous cars, and healthcare autonomous. Scalability is very high. It can handle the thousands of publisher and subscriber at a time. Here, the data is sent to the subscriber without a middleman or without a broker. It defines the structured data types, not just a raw messages. It is suitable for microsecond level response. The another type of IoT data protocol is CoAP, that means Constrained Application Protocol. The packets in CoAP are much smaller in size when you compare it with the HTTP TCP. It is operated to the UDP, User Datagram Protocol. Here, the sender sends the request message. After receiving the response from the receiver, it will send the data to the receiver. It uses the confirmable and non-confirmable as a tags for request response messages. Non-confirmable messages are come under the label of fire and forget. Here, the client sends and receives the data from the server. It is used in the home automation, smart agriculture, smart cities, in parking systems, street light, and waste management systems. The server in CoAP is the IoT device that provides the resources, that means data or service, and responds to the client request. The server is used to store the information. The next IoT data protocol is XMPP, that is Extensible Messaging and Presence Protocol. It is open standard communication protocol for instant messaging, presence and real-time data exchange. It will send the message at the instant in microsecond level response, and it will gives the presence of receiver side. It will gives the online offline status, and it will gives the real time data exchange, and widely used in the chat apps and IoT. For example, we are know the online and offline status for the chat apps, and anyone can run the XMPP server. It is not based on the any company. IoT network protocol. The next type of IoT protocol is IoT network protocols. It handles how the devices are connected and communicate with each other. The first one is WBAN, that is Wireless Body Area Network. It is a short range communication, usually a few meters around the body. Sensor network. It small devices like a ECG, pulse, or temperature sensor, pressure sensor are connected to the base station. Real time monitoring. It is low power consumption. Sensors are often battery powered, so energy efficiency is critical. It is used in the health monitoring and fitness tracking system. The sensors are attached in the human body, and the data are sent to the gateway or node. From that, the data is sent to the base station. From the base station, that it delivers the data to the internet. We can track the information anywhere by using the website. The next one is wireless personal area network. It is it uses the some high range, that is 1 meter to 10 meter. Uses the connected devices like laptops, smartphones, tablets, headset and IoT devices via Bluetooth or Zigbee. For example, the Bluetooth headset, printer, wireless mouse, laptops, mobiles are connected to the base station. The next type is wireless local area network. It connects the devices over a limited area like a home, office or campus using a radio waves. For example, in our home, we are connected to the Wi-Fi network. The range is 30 to 100 meters. It uses the access point central device that connects the wireless clients to the network. The signal will goes from the router to the access point. This is the access point in our home or a campus. We can utilize the network by using the access point. For example, home Wi-Fi networks and public hotspot. The next type is WMAN, that is wireless metropolitan area networks. It covers the large area than the wireless local area network. It will sense the data up to kilometers. It connects the multiple wireless local area networks, offices, buildings across the city. This is the base station. We can receive the signal. It will send the signal to the companies, vehicles, houses, roaming user around the city. Wireless wide area network. It is capable of providing the communication across the globe as well. For example, we are receiving the cell phone network from the satellite. The satellite will give the signal to all the base stations in the city.